Summer is a special secret agent covered up as a graduate student living at the very heart of the nation's capital. Little does she know that her identity might soon be discovered by a crowd surveillance system developed by the U.S. Department of Homeland Security. The project, codenamed BOSS, stands for the Biometric Optical Surveillance System. It uses two cameras to take pictures of the same subject from slightly different angles in order to formulate a three-dimensional signature to be compared against a watchlist database. Although the system is not ready for use, researchers say they are making significant advances. Dr. Buhan Sukik, the director of West Virginia University's Center for Identification Technology Research, explains how facial recognition technology enables computers to detect faces in the crowd.
Typical face recognition algorithm determines the position of the landmark. Landmarks can be the center of your eye, the tip of your nose, the sides of your eyes, the beginning and the end of each of your eyebrows, the tip of the chin, and all these things. And then face recognition algorithm basically measures, these are the traditional algorithms, basically measures the distances between these things. Because based on these distances, we are different from each other. And so that's one type of algorithms. The other type of algorithms measure the texture of our skin. And based on the texture of the skin, that can be either considered separately or together with the landmarks, and then you can enhance the performance. Newer algorithms are now emerging that are, in addition to these relatively simple measures, are trying to include the third dimension. So, for example, if you have an Xbox at home and you have an Xbox 360 camera, that camera has a certain level of the depth perception, and through the depth perception, now, for example, the 2D image of your face can be perceived in the third dimension, so someone can know, for example, how big your nose is or anything like that.
The biggest bottleneck in facial recognition technology is to find the best way to model faces. Illumination and head rotation variations are the two main challenges. The presence of glasses, facial hair, and clothing might also affect the accuracy. When the technology is applied to real-life situations, how accurate will it be?
In order to give the number of the accuracy, one needs to exactly define what it means and under what condition has accuracy been measured. So you actually have many reports that come out of the National Institute for Standards and Technology, which accurately measure the performance of face recognition algorithms, and they offer very detailed explanation of the type of images and type of technology and all the environmental conditions under which they obtain those results. So if you go to their website and read a couple of reports or just the executive summaries, you will see that the performance numbers for well-defined conditions are somewhere in the high 90s in terms of accuracy. But then this is also very different. Am I only trying to verify my own identity, which means am I always asking, is this me or is this that person? Or are we asking, is this person one of the people in this data set of bad people or good people or some kind of people, right? So there are many factors, and giving numbers is always depends on that.
Professor Meg Ambrose at Georgetown University studies international technology policy. She explains how facial recognition technology might pose a threat to privacy concerns.
I think that this is an excellent time to be having a conversation about spaces where we are not identified and can be sort of this traditional definition of privacy where we can be left alone. And that used to be, your home. When you were in public, you could be invisible, and these spaces are shrinking. But I think the bigger question is really about government surveillance and being able to be identified no matter where we are based on this, and it also being tied into all of these other data points from companies, agencies, us, right? We send these signals out. So the privacy concerns that we get into are generally about the government's ability to find you, identify you, follow you, and know these things at kind of a granular level. We've been talking about that this is the Fourth Amendment, right? Protects you from unwarranted search and seizure. And we've been talking about this in terms of a mosaic theory, where if law enforcement can get this really accurate picture of your life, then maybe they've crossed some line and they need a warrant to sort of build that image with all of these different data pieces. And I think that facial recognition is a piece of that, right? It's a really significant piece of that. But it's really, I think, whether it can be used gets into pretty traditional due process questions about whether whether there's reasonable suspicion that you should be identified as someone that's related to a crime. And the accuracy rates of these systems make that a really difficult question to answer, whether you can be identified, question held based on that type of information. Using the government using corporate data falls under ECPA, Electronic Communication Privacy Act. Surveillance laws, the Fourth Amendment certainly prevent some of these things. There's no regulation, to my knowledge, on facial recognition as a specific technology or identifying practice. The corporate governance has a lot to do with whether people have given notice and consent to this. Again, when you're in public, all of the rules change, right? And so it's a messy space. But for the most part, facial recognition is just one of many types of data that's collected about you and processed. And so I think that's why it doesn't have specific regulation, and is only challenging because it's an additional way to identify people in public spaces based on a visual as opposed to textual or numerical form of identification.